Alright, so today we're presenting a report over a fixed wing drone. I'm Ian Bermudez.
And I'm Slayer James.
Alright, so we're going to talk about a little bit about the intro and the background. Our report is to be tasked over estimating a cost of over 4,000 units of a fixed wing drone.
Each group was, there's three different types of drones. There's a fixed wing, rotary blade, and a hybrid. Of course, we were assigned with the fixed wing. And so we all had different ideas with, like, the distance and the weight and how much each drone could carry. But of course, like he said, we were assigned to estimate 4,000 of those. And each drone is different, of course. So that was a big part of it.
Yeah, and also the drones were mainly used for a new usage of delivery systems. Of course, drones are commonly used to, like, the military to survey areas of, like, terrorism and stuff like that, but now they're being integrated into new uses for community. And right now they're testing delivery systems with drones to where they can use a fixed wing to travel a distance of 10 miles in a radius. And it's very efficient to the absence of avoiding gridlocks and traffic systems, and also adding fossil fuels to the air. So it's a very healthier and friendly environmental usage of delivery systems.
Yeah, bouncing off what he said, another way that drones are being used now, just off the military and all that, is like delivery. They're trying to advance the way mail gets delivered and all that. So they're trying to find ways for drones to be able to carry a certain amount of weight or be able to go a certain amount of distance without someone sitting behind the controls, by just being able to program it. And so that plays a big part today in this world.
Alright, so the problem. So we had to figure out the best cost estimate of creating a fixed wing drone. And so in order for us to get into the assembly, we researched in our own time, finding feasible companies that sold products to build our model. And the fixed wing drone had about 3 different frame models that we could have used, but the Skywalker brand was the most popular in terms of being more cost efficient with a decent velocity speed of delivery system and flight time.
Yeah, another thing is like we were trying to find a drone that was also very light, so then it may be able to carry more weight or be able to get to a distance faster, because the more weight you have, the more battery you can take. And so we're trying to prevent the drone dying from mid-flight to point A to point B. We also had some different things go on. Some of the assumptions that we had was a fixed wing drone. Of course, it's a Skywalker brand, like you said. The burn cost was $145 per hour. Cost per part was multiplied by the number of units, which could have been 4,000 or whatever we were doing at the moment. Part costs were singular. Only the model were estimated to be bought in bulk. Parts were sourced from reputable companies, And all fixed drones are identical. There's no variation in color, size, or material, or capital investments were already acquired and not included in the estimate.
And one last thing, most of the parts that we gathered into our report were outsourced from outside of the country, because some of these products were more sufficient in being cost efficient to our whole assembly. So we seeked out products that were more quality over quantity, so that way we can have an efficient representation into the company's model. Alright, so the estimating level of parts. So we discussed how we bought the model in bulk, meaning that the airframe itself already came pre-assembled with some attachments. So because of this, our estimated parts and list cost was about $4,064.50.
And due to being able to get the parts in bulk and not having to assemble each part, it did lower our labor to 2.2, so it makes it faster to build and we can produce more, and it drops our labor costs to not being so crazy. And so basically we ended up with $319 for labor cost.
So for every unit of fixed wing drone that we were to assemble per se into our company, we would have at least spent a total of $4,383.50, and the total cost for about 4,000 units of it would have been $17,534,000.
So now, like, a big part is, you know, we got our estimate, but now we looked at our professor's estimate, and it wasn't, his numbers look bigger than ours, but the thing is that our parts were in bulk and already pre-assembled, so it made it a lot cheaper for us to produce our product faster and more efficient. And so he got the actual parts listed cost at $6,929 compared to our $4,064.50. And then for the actual labor hours it cost, he got 8 hours in 0.625 with the cost of $1,250.63 per drone. And we got, of course, the 2.2 for $319.
Yeah.
And so it looks like big numbers, but you have to understand that we use different parts, and we also had the assumption that our parts came in bulk and we weren't assembling each part to add on to our labor time and cost. Of course, the final cost per unit was $8,179.63 compared to our $4,383. And then for 4,000 units of it, $32,718,500. And then of course ours was the 17 million, I'm sorry, 534,000.
So after looking at the the actual with the estimate, we tried to compare and contrast and see what we did wrong. And like we discussed already, so there was a huge difference between the cost and the executed labor. It was about $3,796.13. It was a pretty big difference between the cost of the per unit of a fixed wing drone. But also a lot of the actual parts list had some parts that were not included on the estimate, and we kind of assumed that this wasn't added to the estimate because it was already assumed that it came with the pre-assembled, so it wasn't part of the parts list. And so, like the servo and the landing gear was all added to the actual actual part cost, and so none of that was into the estimate. So that could be why there's such a huge discrepancy on the difference between both of those results. And if you want to talk about the labor.
Bouncing off what he said, of course, the estimate was different. It was a pretty big number, but our labor is also going to be different because our parts came pre-assembled, like we said. So it drops our labor hours down, which drops our labor costs down for us to be able to produce the product faster and, of course, cheaper for us. And so, you know, the difference was $931.63, which isn't bad. We just had the assumption that our parts were going to come pre-assembled. And so, but that's the best part about this project is that there's so many assumptions or so many like things you can do, and every project's going to be different. You can't get the same numbers. It should never happen. And if you do, you didn't do it right. And so that was the fun part me and him were talking about, is that we were able to find different ways to build drones in just the one way that you provided.
So, you know, as to pretty much sum it up, we thought about, you know, what are our options, what could we have done, and, you know, maybe there are better options on doing it from scratch with cheaper material. I mean, yes, the labor hours will be a lot more higher than what was the actual, but we feel just that most of the pre-assembles already come equipped with the necessities that cost our labor hours significantly, which helps not just the company, but also, you know, the end of the quarter funds that the company delivers without paying their employees so much.
Yeah, exactly. So, I mean, there's a lot you can think about, and there's a lot of things you can do. So we could have literally broken down from, you know, each wire, got the price per wire, the price per putting all those wires together and all that, but that's a lot to put together, and it's a lot to find. And so we had came up with the assumption that it was all going to come pre-assembled.
All right, cool. Any questions? Awesome.